This is Shakil Ahmed. In this tutorial, we will discuss about least absolute shrinkage and selection operator regression, that is known as Lasso regression, which incorporates the penalty term based on the absolute value of the coefficient. Here you can see in ordinary least square method, while minimizing the sum of square, we add a penalty term that is called L1 regularization with a penalty parameter alpha. So the alpha basically shrinks down the parameters to zero, which has smaller effect and causing high variability. So the primary goal is the feature selection and prevent overfitting. Basically, we want to select the set of predictors which are more important in predicting the outcome, and it also adjusts for the bias and variance. Then it makes a trade-off between the variance and bias by making an appropriate value of alpha. Basically, when we increase the value of alpha, the variance tends to increase and the bias tends to variance tends to decrease, and on the other hand, bias tends to increase. So we will try to make a trade-off between variance and bias. So this is a widely used technique for variable selection. When we have a lot of variable installed, we need to narrow down the number of important variables based on variable importance. So in this tutorial, we will just demonstrate how we can select a set of variables based on variable importance using Lasso regression, that is called L1 regularization method. So we start again with the strokes prediction data. Here we are interested in predicting the average glucose level, and based on the rest of the variables. So we have uploaded the stroke data set already here. If you have not uploaded, you can just upload using this option. And then we read the for reading the CSV, we need pandas library, and then we read this stroke.csv using the command pd read underscore CSV, and then we can see first few observations. For example, if you want to see first 10 observations, 10 rows, then you can just write 10 here. So this is some detail about the Lasso regression, and now I'm going to import different packages. We need this seaborn package is used for visualization. Basically, we want to see the feature importance plot, or we can also see the heat map, and the matplot library is also used for this purpose. And then for train test split, we need a train test split from the model selection, and scikit-learn linear model we import rich, that is it is also a type of regression. And then scikit-learn dot preprocessing import standard scalar and one hot encoder. So one hot encoder makes the converts the categorical variable to on numerical scale, making binary variable for each category. For example, if we have three category for you can see any variable. This variable we have two categories, urban and rural. So it will create uh, two binaries, one for urban and one for rural. So we can include them in model. But if we have two categories, we should have only one dummy variable. Otherwise, we should omit the uh, intercept from the model. Otherwise, it it would cause it will cause the perfect multicollinearity. So we should be careful while making the while converting these multiple categorical variables to the binary one. If there are only two categories, then we can just make a binary for only one. For example, we can make a binary using 1 for urban and 0 for rural. So the one hard encoder command is used for, library is used for date, and standard scalar is used to standardize the data to make mean 0 and variance 1. And you also need column transfer if you want to transfer certain columns, and the pipeline command also. This is used for regression, and I think we can check for the lasso as well, whether it is required or not. And then mean squared error and r square are the performance metrics that is we imported from scikit-learn matrix. And then df clean, we just remove the unnecessary columns from our data set, the id column. And then the we also uh, impute the missing values by their mean, and as the BMI has missing values, so we just replace them by their mean values. So we can run this, and then we have already run this. And then we need to specify the response variable, that is average glucose level, and the features. Feature variable, we have excluded the average glucose level. We have two variables with same name. So we excluded both of the variables, and we also exclude the stroke status. You can keep as it as well as the predictor. But stroke status does not predict the average glucose level, so we just excluding this from the analysis. And then we just make the dummies, that is x encoded pt get dummies and x drop first true. It means the first category will be removed, and it will make a binary for the all the categories. For example, if we have three categories, we will get two dummies, and if we have four categories, we will get three dummies, and so on. And then we can just see the feature names which we get from encoded data. So these are the features. For example, age is already on numerical scale. Hypertension is all only, it has only two categories, so we have only one dummy. Heart disease also has only two categories. It's already in dummy form. BMI is numeric, and gender male. So gender has three categories. So we made two categories, one for male and one for other. Although we can exclude this, then we are omitting some data set. And then our merit, yes, means it has also three categories. So I think two categories. So we just made one category. Your merit yes or no. So no is the reference category. So similarly, we get all the dummies for all the variables. So this command is a good, just get dummies and then x, then drop first is equal to true. It means we are keeping only we are removing the first category and keeping that as the reference category. And then test, we converted the, we separated the data into test and training part. The X encoded we used, and the Y we have already defined here. We just divided the data into test and training by keeping 20% in test set. And then we standardized using the standard scalar command, and scalar dot fit transform x train, and similarly we can do for x test. Now we need to fit a lasso regression. So lasso, uh, we need to specify the value of alpha using less cross validation. So we will fit a lasso cross validation with cross validation 5 uh, fold cross validation, and with random start fold 2, and then x train y train. So we fit a lasso regression on x train and y train, and we get the best value of alpha, that is 0.3084. It means 0.31. And then we will just based on the lasso fitted here, we can predict the y values, and then mean square error, and then r square. Although you can refit the lasso using the uh, cross-validated value of alpha. It is already using basically the lasso CV are already fitting and the value x trend y trend based on the 5-fold class validation, and the value obtained is 0.30. This is using the value 0.31 already. And then we can make predictions, and then we can find mean square error and r square using the mean square error. We have already imported this library mean square error and r square score, and we can see the mean square error is 1866, and the r square is 0.06. And we can also see the shape of data. We already ex, separated data into test and training, so we don't need to do this. Can just separate this, and then in final we need to uh, see the feature importance based on the coefficients. So we, from the lasso fit, we just find the lasso coefficient, and then features, and these are the columns of x, and then we can create a data frame with feature as features and coefficients. So we will get this data set, and coefficient reindex with coefficient absolute dot sort values. Basically we just obtain this value sorted by uh, the coefficient values. You can also do it in descending order, as ascending is equal to false. And then you can also make a nice table and just copy it and use in your analysis. Okay, just make it, just copy here and paste in Word. And then we see the variable importance plot. You can see the variable importance. The most important variable is the age, followed by BMI and hypertension. And how we can do this? We can just use the plot figure. This is used to set the figure size, and then coefficient, feature, and coefficient data frame coefficients. These are the names, and these are the values. And then on x we have coefficient values, and on y-axis we have the variable names. These are variable names, and these are the values. And then we are just giving titles, and then we have a title layout, and then will be a tissue to show the figure. And we can uh, just show these. If we want to select the variables with non-zero values, then we can do this just from above data frame. You can just do coefficient data frame. This variable is should be not equal to 0. Even you can select those variable which has higher values of coefficient, and in some cases we can check for the significant variables which are giving significant p-values only. We return to the model. So in this way, lasso regression is a good tool for select model selection when we have a large number of data set, high dimensional data with a large number of variables. We just select the most important variables and use those variables for prediction. So thank you for giving concentration.